And we think Ganymede has retained enough of that heat to produce a saltwater ocean with more water, actually, than all the oceans of the Earth combined below the frozen surface of Ganymede.
A strange giant moon with an ocean and aurora, nearly 1 billion kilometers away from the sun.
We're talking about potentially a habitat for life. This is a big world, a planet-sized moon, which has a magnetic field and a saltwater ocean and a ready source of energy, it seems. All the things that we think are necessary for the origin of life. And it's important because we used to think of what's called a habitable zone around a star, which is where the Earth orbits, and indeed Mars and Venus just about, which is the zone where you could potentially have liquid water on the world, on the surface of the world in that case. But now, looking at places like this, we understand that there might be habitable zones far away from stars. In this case, a habitable zone around a gas giant. And that habitability here is delivered by gravity.
Leaving this distant ocean moon behind, we head inwards on the final leg of our journey. Passing through the asteroid belt, rubble left over from when gravity failed to pull a planet together. Until we reach the inner rocky planets. The worlds here are home to phenomena and landscapes that are mesmerizing. So strange and alien. But amongst all these wonders lurks perhaps the strangest world of all.
Welcome to Earth. It is the biggest rocky world, radius about 6,370 kilometers or so. It's a bit unusual in that it's got a single moon, but the thing that makes it very unusual indeed is the presence of that liquid water on the surface.
You might not think of Earth as strange because we live on it, but it is, in fact, a very rare world.
Yeah, this is a really wonderful and unusual thing to be able to do in our solar system, because there is no other world where the conditions of temperature and pressure on the surface allow liquid water to exist. It's a very narrow range, and that range is set by the details of our atmosphere. There are tons of atmosphere pressing down on this rock pool to stop it from boiling away.
The nature of our atmosphere is defined by the history of our world, our place in the solar system, and gravity.
Now, if you imagine that you'd reduce the mass of the planet just a bit, then the pressure would fall and this would boil away. If I carried on doing that and reduced the gravitational pull some more, the whole atmosphere would disappear off into space.
All the myriad properties of our planet have combined to allow liquid water to persist here for over 4 billion years. Leading to planet Earth's most unique feature. life. As we explore the solar system, we are discovering ever stranger places. All born of the interplay between beautifully simple laws of nature and the deep history of each and every world, creating endless wonders of the solar system. Including us.
Just look at these telescopes, our eyes on the universe. I find it so remarkable that on one strange world in our solar system, collections of atoms have come together that can do astronomy. Because there's nothing particularly special about the Earth. It is just another lump of stuff that's found a way to avoid gravitational collapse. But somewhere in between the relentless inward pull of gravity and the sheer bloody mindedness of matter, some of that stuff has found a way to contemplate its place in the universe.
No other planet has rings quite like Saturn does. They're beautiful, but it's odd to think that they might not be there forever.
Far from a permanent structure, we now know that these strange loops of rock and ice are constantly changing and may one day disappear completely.
We have big questions about Saturn's rings. How old are the rings? How did they form? And what is their evolution like? How long are they going to last?
NASA's Cassini spacecraft studied Saturn and its rings for 13 years in search of answers.
Cassini allowed us to see Saturn from closer up than ever before, but also from new vantage points that we had never been able to access from the Earth.
Cassini witnessed a series of bizarre moons, clearing paths in the rings. But one of the biggest insights came from its encounter with a strange kind of rain falling onto Saturn.
It was Voyager that gave us the first hints that particles could be falling into Saturn. Towards the end of the Cassini mission, when we flew the spacecraft between the rings and the planet, we were able to detect small ring particles that were falling into the planet, so-called ring rain.
The immense gravity of Saturn is pulling on these particles, eroding the rings.
Ring rain causes the rings to slowly die. But what we don't know is the rate at which the rings are perishing. We just know that they are.
Flying through the icy rain falling from ring to planet was one of Cassini's last endeavors. In 2017, the mission came to an end before Cassini could find out how long the rings had left. To get a definitive answer on the lifespan of Saturn's rings, we needed a brand new mission.
So JWST isn't like a normal telescope that you would find on Earth. It's not at the top of the mountain like the big telescopes that we have here. Instead, it is 1.5 million kilometers away in space.
The Space Telescope is designed to peer into the depths of the universe. But its infrared cameras are also showing us our solar system in a strange new light. Illuminating the faint rings around the outer planets normally invisible to us.
It's extremely difficult to get to the outer solar system, and so an instrument like JWST that can look at these distant objects is invaluable.
Amongst its targets is Saturn and its rings, where the hope is that the telescope will be able to help answer how fast the ring rain is falling.
So the rings are made of mostly water ice, and some of the smallest pieces flow up the magnetic field and fall into the planet. That happens all the way around. So in our observations, we see this kind of infrared glow all the way around the planet at that location, which indicates that there is ring material flowing in.
In the next few years, JWST will measure the intensity of the infrared glow in that band, revealing how fast the rings are losing particles.
I'm very excited to find out how quickly Saturn's rings are eroding today, because finding out what's going on today is really important for mapping their past and predicting their future.
Bringing us ever closer to understanding exactly how long Saturn's stunning rings of ice are likely to last.
There's something about seeing Saturn's rings. You have this almost childlike fascination and a professional curiosity that come together in a very unique way.
Knowing that Saturn's rings won't be around forever and that we're here at the exact moment when they are here is really amazing. I feel really lucky that we get to experience them.